Okay, good evening, good morning, good daytime, wherever you are in the world. Welcome to the first of our LIDNUG sessions of 2014. I hope you all had a very good new year and enjoyed the festivities immensely. Just the usual stuff first. Got to say a shout out to our sponsors, Orcsweb, Telerik, Pluralsight and Syncfusion. Guys, as usual, without your help and assistance, we really wouldn't be able to keep doing these sessions. And your support is greatly appreciated by ourselves and the rest of the community. The usual stuff, you can reach us at lidnug@lidnug.org. www.twitter.com/LIDNUG, Facebook LIDNUG, YouTube LIDNUG, and BitLive LIDNUG. For all those who will ask the question, this presentation will be recorded and it will be uploaded to our YouTube page after the session finishes. In February, we have Architecting Cross-Platform Applications with Ross Dragon, and he'll be showing us how to use... yes. Okay, I can't quite hear that. Ian, can you just mute your speakers a second for me, please, mate? That's better. We have on Wednesday the 12th of February Architecting Cross-Platform Applications with Ross Dragon, where he will be teaching us all about Xamarin and what it can do to help make your applications more portable. Tonight we have Ian Cooper, who's a mainstream software developer here in the UK. This is Ian's first LIDNUG event, but by no means his first presentation on TDD ever. He has 20 years of experience in software development on the Microsoft platform. He's worked for many big name companies, amongst which are Reuters, Sungard, Misys. He's a regular speaker on the UK circuit, and he's presented at places such as NDC and other large events. He has some videos on Vimeo as well, which I would seriously encourage you to go and watch after this session is over. That's all we've got at the moment. The session will be recorded. You have the Q&A to put your questions in, to put questions to Ian as he's going, and he'll answer them as he goes along. That's all from us for now. I'll hand you over to our presenter. Ian, take it away, mate.
Hey guys. Right, I apologise for any Falmans moments when we get going. I'm not a bit new to the process of doing this kind of online presentation, so hopefully you'll bear with me. Okay, so tonight's presentation really, for me, is really, I kind of think of it as rebooting test-driven development. Those of you familiar with kind of like genre comic books or science fiction shows probably get this idea of when someone says, hey, let's get back to the beginning, let's cast away the kind of craft that's built up over the years and really go back to the essence of what this idea was and start again. And having been doing TDD since 2003, 2004, I have observations from a number of years of experience of doing it that suggest to me that we need to really go back to its roots, remember what it was all about, and really throw away some of the craft or misunderstandings that built up over the years. And this presentation is really about those misunderstandings, and it's from some hard-won experience at other folks' expense, really. Okay, I think you've heard most of that, so there's not much to that. Okay, so the agenda we're going to talk about, there's a couple of bits missing from that. Actually, I wonder if this is the right version of the presentation now. Yep, it is. Okay, it's fine. We're going to talk a little bit about the kind of problem we're facing. Actually, this is not the first presentation I want. Hang on a second. Let me just see if I can share the correct version. Let me just go back. Okay.
Is everything okay there?
Yeah, I'm just switching versions of the presentation, which will just take me a moment to flick through things, but
Not a problem. Just bear with us, folks.
okay. Sorry, guys. Okay, that's the output I work for. Those of you who don't know who Huddle is, we provide a online environment for people to do project-based collaboration, similar to SharePoint in the cloud. It's worth checking us out if you want to alternative to SharePoint. Okay, so the agenda. So the first thing I really want to talk about is what is the problem? Why do I think we need to go back in time to look at TDD again? The second thing is really to actually then kind of reboot TDD for you. What is the core essence of TDD? What is the chief things we need to understand to really get TDD right? We'll look at the red green refactor cycle. What I want to do is walk you through that, even though you might be familiar with it again, to highlight where I think there have been some significant misunderstandings on the purpose of that cycle and how you approach it. So about the notion of clean code being, you know, what we would all want to achieve for maintainable software. And we'll talk about how that fits into that TDD red green refactor life cycle. We'll talk about patterns, how they come into play in TDD. And then we'll talk about a number of things that could help us, ports and adapters, gears, ATDD. We'll talk about the relationship with this presentation with ideas like behavior-driven development. If we get time, we'll run briefly through mocks, object model tested builders, and additional questions at the end. It's quite a packed agenda. Let's move on with that. Okay, the problem. When I first started introducing TDD to developers on teams I was working with, one of the most interesting things I found was that it was generally some of the most experienced developers who really resisted doing TDD. In fact, a guy that worked for me in a kind of second place, I was really practicing TDD when I was really helping them convert, said to me after a while, Ian, yeah, I get why the junior developers in the team ought to be writing tests. But I know you don't expect me as a more senior developer to need to write tests. And at the time, you know, you think, oh, the guy just hasn't drank the Kool-Aid, he doesn't get what we're doing. But he wasn't stupid. He was a really smart developer. And so the question really became to me over time, well, why did the smart developers really resist test-driven development? One of the other things I noticed over time is I've had, you know, various projects with collections of test suites. And at first, those test suites, while you define the software, are incredibly helpful. I delivered a project which is essentially a pipeline used for production of documents in the insurance industry, and we wrote that with test-driven development. And you know, this thing had 0 defects and ran for a long period of time very successfully. But one of the problems we hit was that every time we tried to change something, when there was a new requirement or specification, we should spend a lot more time fixing broken tests than we spent actually writing the code itself. I don't know if you've had that experience, or if you go in and you change something and there's a sea of red suddenly in your unit test suite. And the trouble is, it doesn't seem to be right, because one of the ideas about the refactoring cycle, as envisaged by people like Martin Fowler, or this notion of changing implementation details in the presence of tests, is that the tests remain green throughout refactoring. And if they were going red, we're not really refactoring, because it implies we're changing some kind of details that the tests should be keeping green. So the question is, why did you tell me to test break? You know, the test for the behavior that I'm changing, I can understand that, but there was a spray of red. On that other same project, we wrote probably 3 times as much test code as there was actual implementation code. And we asked around various other people. I was blogging quite heavily on Kent Beck at the time, and spoke to some of the guys there, and they were all bringing back similar stories. Yeah, you know, quite often you might write twice as much test code as you write implementation code. And that might seem fine to those of us that are really bought into TDD, but part of the problem seemed to be that was really slowing us down. We were taking a lot longer to deliver. Yes, we're delivering high quality. Yes, when you took out the usual cycle of test and debug and fix that you can get trapped in during a kind of acceptance testing. We were much faster through that, but you couldn't help feel that perhaps we'd overcooked this. The other thing that some of you may or may not be aware of is there's a movement in some what you might call post-agile methodologies. I would say they're chaos rather than agile, but that's a different story. But they have things like program anarchy or lean software, spike and stabilizer, are all doing away with test-driven development. They're saying don't do test-first development. They have various reasons to do with a philosophy of throwing the code away. But the key problem seems to be for them is that tests are seen as a burden that you can't afford to pay. Some of you might be kind of aware of this notion of the duct tape programmer, the guy who sits in your organization who hacks code that when you look at it you think it's horrible, it's held together with chewing gum and string, but the customers, the business, the product owners, they love him because he's productive, he gets stuff done, he ships product. And they look at you with your, high-quality engineering principles, and they can't understand why you can't be like this guy who's just constantly delivering. One of the other promises that we looked at that really just didn't seem to be as true as we'd hoped was this notion that if we have a good test suite, it's documentation for our code. When a new developer joins the team, you'll be able to look at the tests, understand what's going on, and this will form effective documentation. And we also found when we went to look back at tests ourselves, we couldn't really understand them in the context later. I mean, even tests I'd written myself, 6 months later I come back to them and I think, well, what was that all about? And the problem was that sometimes you would change your code for a new requirement, and a test would break for some old requirement. But it was difficult to tell whether the test had broken because the implementation was incorrect, or whether that portion of the requirement was affected by this new requirement, which they had to change. The tests were too technical. They were too low level. We couldn't really understand the behavior we were trying to basically get hold of. The other thing is that I spent quite a bit of time really in the field of acceptance test-driven development. So particularly I was using Fitness, and I led a team for 2 years through building a large Fitness suite which they ran and maintained for some period of time. And it was quite a bitter struggle. They really didn't want to run those tests. They spent a lot of their time red, and I had to really crack the whip and say, come on guys, you need to get these tests done. We had to put a lot of process around making sure these tests were green and saying you can't commit, or if until they're green locally. When you get into the server, you've got to hold the token until you get them green. And it was a real struggle. And the problem is that I don't know they had a lot of value, and SpecFlow is a very modern example of this. We didn't get the product team to have a look at them, and the developers just really resisted it and just said, we want to get on with building software, not writing these fitness tests. And so I began to feel that maybe TDD was becoming more of a burden than we'd originally hoped. But I also thought that TDD might be more of a burden than when we'd originally kind of started. And so I wanted to really think about how I could re-examine my practice and the practice of my team at Huddle and figure out where we could make some improvements to what we were doing. So this idea for me is of rebooting TDD is kind of unlearning the bad habits and going back and focusing in again on what TDD is all about and trying to drop some of the sort of stuff that's picked up over the years. One of the things I do quite often is I go and reread this book. It's Kent Beck's original book on test-driven development. It's a really good book. It gets some poor reviews on Amazon. Don't worry about that. The guys writing those poor reviews are foolish. I think they don't like it because they want something that's less of a book about the zen of something, more that is a detailed, chapter by chapter, holding your hand set of instructions. And it's true that in some ways this book is perhaps better once you've done a bit of TDD yourself and you can go and read it and say, okay, this is what the guy's getting at. But it's also very comprehensive. For a book that was written right at the start of test-driven development, it covers a lot of ideas, mocks, builders, acceptance test-driven development, that we kind of thought in many ways, mocks as well as patterns as well, smells, kind of a lot of ideas that you might have thought came later and emerged in later practice and built upon a very simplistic model of TDD, but it was actually all here originally, and Kent had some, very strong opinions about it, which in some later writers didn't respect or pay attention to what he was saying, and I think actually paying attention to his original insights has a lot of value. So what I wanted to do at this stage is really give you an idea from that book as to, this is the heart of the talk, what I think the problems are with existing test-driven development practice when we go and look at Kent's work. And the key for me is that we have spent too long testing what I would call the implementation details of our code rather than the behaviors. And particularly the problem surfaces from an approach to TDD which has us testing classes and more particularly methods on those classes. So there's a TDD lifecycle which is pitched by a number of teachers and a number of books out there, which essentially says you go to write a method on your class and you test the method on that class and you test it by passing in various parameters and making sure the results come out correctly. And the problem for that is that it loses all of the behavior of that test. And believe it or not, although we may think of behavior-driven development as a new thing, behavior being the instigator for writing a test is what TDD was originally all about. I'd also say that we want to test outside in. So you want to work from your kind of use case requirements rather than the implementation details. So you want to work from the outside. Now, the BDD guys picked up on this and they tend to quite often focus on testing against the UX layer. I would not do that. There are various reasons for that, but essentially tests written against your user UX are fragile, brittle, and expensive. But I would write just below that subcutaneously your service layer or your ports layer, I'll talk about that later, where essentially you expose the API that drives your code. And it's that API layer that you want to actually target. And if you write tests against behaviors, the use case of behaviors in your system are usually expressed at that service layer. What I would say is that that service layer, where we're expressing the behaviors, is where your test should be focused, not the implementation details. That's the public behavior. That's the bit of your modules that should be public. And we spent too long really testing things that should be internal or details of our modules and exposing them as being public or using assembly visibles, internals visible to expose them. And this is not the goal of TDD. The goal of TDD is to test a public interface when we spend far too long reaching into those implementation details. Okay. That's the kind of crux of this talk. That's what we're going to try and prove to you that you should be doing. Some of you may be doubting that assertion right now, but bear with me, and I want to really talk about why I say that's how we should be doing TDD. So for those of you with end-tier architectures, you've got your presentation layer, you've got your services layer. It's kind of that layer. At the services layer, I think you should be writing your tests. Those of you with the ports of that architecture, I'll explain later. It's really the ports layer. That's your public API, which you should be, since API not in the sense of other websites consuming the REST API, it's the API of a module, it's the exposed interface. If you think about an assembly has classes it exposes outside, those are your public classes, those are your kind of your contracts, your APIs, those you should be testing. And sticking away from those implementation details is why you're having refactoring trouble. Okay. So I wanted to mention Dan at this point and behavior-driven development. Some of what I'm talking about here is really a similar observation to what Dan had originally when he began the behavior-driven development movement. Behavior-driven development right now is a full-stack agile process and doesn't bear much relation to what I want to talk about here. But it's hard. Dan had a post when he created this idea of behavior-driven development originally, where he said, I've looked at the way everyone's doing test-driven development, and it bears no relation, as far as I can tell, to what Kent was originally talking about. He was talking about testing behaviors, and if we change the name of test-driven development to behavior-driven development, folks will get they should be testing behaviors rather than methods and classes. Now that went on to become a whole swathe of things like JBehave, and then RBehave, and various other testing frameworks. NSpec is, if you like, a .NET equivalent that drove that kind of behavior-based approach much more solidly. But the crux of it is this original realization. People were doing test-driven development wrong because they were focusing on methods of classes rather than behaviors of the system. Okay. Trying to prove and as Kent talked, typically by example is an interesting book because Kent really demonstrates the practicity by working through some examples. And one of the reasons I don't like the book because it's not a clear recipe-based approach. But I think it's instructive to read the examples because it captures what he's doing. And in this quote here from the book, what we're saying is that he's saying that he's looking at the behaviour that will demonstrate the presence of code or confident will compute the report correctly. And I've highlighted the key phrase there. What he's talking about is saying, I want to write a test that expresses this behaviour. And he's got two particular behaviours he's writing tests for. One is this add two amounts in different currencies and convert the result. And the other is multiply an amount, a price per share by a number of shares and receive an amount. Notice that both of these requirements are behaviors that he's testing. Right? We're not expressing the test requirement as given methods or classes. There may be multiple classes involved here. Okay? It's expressed as a particular behavior the system needs to expose to us. Okay. Kent's quite explicit. What we're doing is we're telling the story of how the operation looks from the outside, how the application programming interface for our code goes. The API is not one class. The API is the public interface to a module. In an enter application, it's the service layer. In a hexagonal architecture, it's the ports layer. This is where we expose our code base. It's not the implementation details. One of the reasons that I think we end up in this model of testing methods on classes or classes is that there's a huge misunderstanding caused by Kent's use of the phrase unit testing. Now, a lot of people, when they talk about unit testing, one of the assertions they'll make and they'll repeat to you is a unit test needs to test one thing and it needs to test it in isolation. So you need to isolate your class, you need to mock all its dependencies, because it's not a unit test, you're not testing one thing in isolation. And that's out of box. Nothing to do with what Kent was talking about whatsoever. That's a true definition of unit testing for the established use of that term within a QA team. But from Kent's perspective in test-driven development, or test-first development if you like, a unit test meant one thing only, and that's a test that was isolated from other tests. So that you could run your a set of tests together, and the results of one test would not impact another test. Okay? So it's about the isolation of the test, not the isolation of the system under test. Once you realise that Kent meant that, and he's very explicit in the book that that's actually what he means, a number of practices that people have in test-driven development turn out to be very cargo-coupled. So one of them is this notion that we need to have a clean separation between our unit tests and our integration tests. And our integration tests are ones that do things like talk to databases, file systems, etc. That distinction is not one that Kent has, and he's very explicit that that doesn't really exist. Okay, provided you can isolate one test from another, it's perfectly fine to touch anything. Now, pragmatically, using a database can make that hard because it's a shared fixture component, and unless I clean the database in between every test, then actually that's going to get quite hard for me to run my tests in isolation. And mocking a shared component can be a valuable way of keeping my test itself isolated from other tests. But it's not about isolating the class under tests, it's about making the test isolated. It can also improve performance of our tests. And quite a lot of teams have a 10-minute build and test rule. So there are valid reasons to do it, but the reason is not that the class under test is to be isolated. We're testing a behavior in another class, and it's just about that particular method running well. So, you know, that notion of integration tests, the notion of are a bit of a scam, the notion of making all my classes dependencies mocked because, you know, I can't talk about anything else is a bit of a scam. And we need to move away from that idea. It's not part of the original TDD. TDD would be quite happy for you to talk to databases during your unit tests. It's no problem for Kent Beck TDD to do that. You may find because your test is slow, and you may find you have a lot of setup and teardown code to clean the database up between each call, which slows it down even more, that you don't want to do that. But the prescription is pragmatic. It's not to do with what a unit test is. So once we kind of get away from that notion of a class being needing to be isolated and accept the fact that maybe multiple classes involved in the testing of one behavior, we're somewhat liberated, because actually we may be able to focus on behavior, and we go and look at our test and maybe find test express behavior rather than methods on classes. So the context then travels with the test, and this problem of looking at our test later and trying to figure out what the context was goes away. This problem of over-mocking, where our mocks know too much about the implementation details of our classes, and therefore when we change our implementations, break can go away, because in many cases we can use concrete dependencies. Okay. So I think this is the first challenge people have, is to re-examine what they believe a unit test to be. And it's certainly not an isolated test, not in Kent Beck style TDD anyway. Okay, so I want to go talk about Redefining refactor, because I think Redefining refactor is really important to understanding how to write this kind of test. Because you may be saying, hang on a minute, well, how does this work in practice if I'm writing tests against my kind of module exteriors and I've written my behavior-based test? You know, how am I getting these implementation details, these low-level classes out? Because surely I'm not writing everything in my API. How do I generate my multiple classes that you tell me I might have? How does the Redefining refactor cycle support that? So we're going to go back and look again at Redefining refactor, see what Kent's actually saying, and show you how the design emerges in a way that supports this model of TDD.
Just before you move on there, you've got a question in the Q&A.
Okay, let me have a quick look. Okay, so given the very question that Robert Martin would say, you should not write any code before you write the unit test, therefore this type of TDD occurs at the lowest level possible at the method class level. We should have a test for all code. Can you comment on this? This method is not opposed to the idea that you should not write any code before you write the unit test. We are going to demonstrate TDD as a test-first operation, where you write no code before you write the unit test. But the lowest level possible is not the method class level. The level to hit is actually the API. Yeah, please explain this. API or Rust. API. We mean the public modules of a class, right? And so we're going to explain how we dive down to get those implementation details by following the Redefining refactor cycle. But it's wrong to say that method on a class is the first entry point. I mean, sure, it'll be a method on a class that we're actually calling under test, but it's not all methods on all classes. I'll explain those as I go through. Okay, so Redefining refactor. Most of us are probably familiar with this, where this cycle works. The first thing we have to do is write a failing test. Okay. And by a failing test, what we mean is a test that proves our test will fail if our implementation is not correct. Tests don't have tests, so there's always a risk around tests that our tests will produce false positives. I'm sure some of you have written code whether you decided to go straight to green, like I've done that in the past, and you found that actually this test would never have failed. It would have always given you a green result, and you can't, you've got a false positive, and you need to really prove it would be red false. One common mistake here is to believe that the red phase is simply you've created a whole load of calls to non-existent classes in your test, and implementing those is now that's the red phase, right? And that's not true. Yes, you do need to provide stubs for all those methods and stuff that you call so you can compile, but getting it to compile is not passing red. You have to actually have a test that not only compiles, but when it runs, results in a red expression to say, okay, under this set of circumstances, the code is actually not providing the correct answer. Right. Very straightforward. Green. The green phase is about making the test work. And the important phrase here is committing whatever seems necessary in the process. Okay. So we are not writing clean code at this phase. And that's the key to understanding how we will actually manage to make sure that we test at a narrower surface area. And then finally, refactoring. Refactoring is where we finally do get clean code. Okay. And it's occasionally also expressed as write a test, make it compile, finally see that it fails, make it run on remove duplication. Okay. So what do we mean by the simplest thing when we make something go green? Well, Kent's really kind of explicit about this. He says essentially copy and paste code out of Codeplex, you know, or a blog that you find on the web. Like the whole thing is a huge transaction script. Just literally get this thing to pass as easily as you can. So when you're thinking about this, imagine that I've got, say, referring to Kent's example earlier, I've got some things adding two monetary values together, and those monetary values could be in two different currencies. Right? And my API says I've got some kind of like currency calculator, and it's just adding these two values. So that's my API method that I'm actually dealing with. And I may actually, as a result of writing my test, have to create some kind of money value types. And I've also got this add class. Well, what I do is just go in and then add method, just literally list out everything I need to do to get this passed as quickly as possible. I'm not trying to write decent code here, right? It may be that actually somewhere inside that I need to use to split this up into more classes because it violates, you know, the single responsibility principle. It may be that I think that actually at some point I'm going to need to be open and closed here. It may be that I feel I need to inject some dependencies. It may be that I think there needs to be some factory creating some bit in here because I've got too many layers of if statements. None of that matters right now. The thing you want to do is get it green, and you want to get it green as quickly as possible. So you just literally have line after line of code, right? Don't try and break up in any more sophisticated way. It's a key idea that you want to write, in a sense, simple code. Now, Kent says, actually, the better the engineer, the harder they find this. Because you're asking them to do something which their instincts fight against, which is not writing a good implementation, just writing an implementation. But his key point is it's very hard for people to do two things at once, and that is think about the design of their code and solve the problem. And I've had this kind of experience before where, you know, you start producing a beautiful little design to implement the code for the tests that they're driving you. And actually, about halfway through, you realize you're solving a different problem to the one that the requirements actually create. And as a result of that, you've got a whole load of cruft in there you don't need. And you start thinking to yourself, well, it might be useful one day, I kind of want to leave the code in, or, well, this design's not quite right, but I'll hack it and I can make it work. And Kent's saying, don't do that. Don't get yourself into that mess. Write the code you need to get the test to pass, and then at appropriate moments refactor that code into a good one. There's a quote from Kent here. Commit any of the sins for speed trumps design, just for that moment. So at this point, one of the key ideas is people talk about test-driven development being a design-based philosophy. One of the real key points here to mention is that the design is not happening at this point. At this point, you are solving the algorithmic problem that you're faced with. You are not doing good code design. Make it run, make it right. But that's really the key to what we're doing here. Right? We're saying actually just write a whole load of code and make it run and make it right. Right. So given that, I've now got an implementation for my add currency method that is just doing some god-awful thing in there that basically makes my test green. At what point might I actually change that into being something decent? Well, the answer, of course, is the refactoring step. So the refactoring step is when we essentially, for example, when we apply patterns. So this used to be this expression that people call pattern happy. People come across design patterns for the first time and will say they become pattern happy because everything looks like a design pattern to them. And one of the problems with going too early to an engineering solution is that often you may find that you've got you force fit the problem to fit your engineering solution from the pattern. One of the advantages of solving the problem first and going green is that when you come to do your refactoring step is you're then moving towards that pattern because it's clear from the successful implementation you've done that's now green that that's what's required. And you can use code smells like feature envy, primitive obsession. Maybe what I need here is actually, you know, to replace these primitives with value types, etc. It's where you can remove duplication between parts and create a new class between, say, two classes that says this is a helper that has, that I inject, that has the common code these two items need. So, you know, my currency conversion thing, I need some lookup to basically go and look up current currency rates, and I'm going to use that here, sort of thing. One of the key points is you're not writing any new tests during this refactoring process. This is the thing that's really hard for folks at first to get across when we go back and look at TDD is you're not generating new tests. Refactoring is changing the implementation details of your code in the presence of tests in a way, and because it's covered by tests, it is safe. If you go look at Fowler's book on refactoring, or you use refactoring tools, you'll find that refactorings are things that are safe to do in the presence of those tests. You can continually be green while you're changing them. They don't require you to go through a red phase at any step. And because of that, I don't need new tests. So if as a result of breaking out this implementation or refactor phase, I break out 4 new classes, none of those classes had tests. Okay? And this is the key point where we get away from that problem of our implementation details being exposed in a lot of our tests. Remember I said at the beginning that one of the problems I quite often had in test suites was that you change something and the whole CS stuff would go red. The problem is that our tests knew too much about the implementation details or the low-level classes instead of just the API. And the definition of refactoring is changing the public interface, changing the implementation details, not the public interface, in the presence of tests. Right? So the key is we can change the implementation details and we stay green because it's the public interface that's actually supported by our tests, not those implementation details. In fact, we can't do refactoring in a world in which our tests cover the implementation details. Because if we do that, we'll have to change tests. Because as we change our implementation details, we'll be changing the supporting tests. It's impossible to do refactoring as originally envisaged in a model where we change implementation details which have tests that cover them. So it's only our public interface, only the contract we have that we have to have tests against. Now, people say, how big is that contract? Where does it live? Well, you know, if we go back old school, we would say, well, an assembly is something that has a public interface where effectively it is the classes that we make public that are exposed to the outside world. They are the tip of the iceberg. They are the kind of 20% that appears above the water, whereas the 80% is inside. So we have the kind of the facade that says, I'm hiding stuff down below here, or the aggregate that basically is hiding its implementation details. That's essentially what your tests are against. The rest is implementation details. And the reason for that is if I want to rewrite how it's implemented, I come up with a better algorithm to solve my problem of figuring out the shortest path for my delivery schedule. None of my tests should break because my consumers don't need to know that I've changed implementation details. And that's why in this phase, there are no new tests required because my API, my contract with the world, has the tests. The implementation just don't need it. Now, coverage tools are really useful here because as you do those refactoring steps, you may want to check that you continue to remain with a high level of coverage to make sure that you're not introducing new paths or branches when you actually break out those inner classes. If you do that, you're missing tests at the API layer that should be driving those changes. Might be something on the outside as a variable that forces you to take that path, and so you need to control that variable on the API layer and have those respective tests. You'll also find, because you've written the test against that higher layer, they tend to be written, when you write against public APIs or services, you're quite often writing against particular use cases. They're more granular, and you should be much clearer when you come back to them about what is actually the behavior that you're testing. So it's quite a challenge for most people because they're used to this comfort model where every class that I wrote tests for it. And so I was really sure that was working. When you say to them, don't do that anymore, refactor from the implementation details of the public API that you've created, they get uncomfortable because they don't have this security blanket of tests anymore. But they do, they just don't trust them. Kent had a really sort of Facebook post, it's sometimes worth following Kent on Facebook, saying, you know, people don't have enough confidence in their tests. One of the reasons we see all these acceptance test suites or all these integration tests is because people have lost confidence in their tests. And in this model where we are refactoring here to produce the implementation details, we already have tests. We had a test against the API, and now they are covering us. The need for additional tests is just not there because you are only writing things that give you the coverage you already have. Okay. So as a result of this, you'll write far fewer tests. And the advantage of writing far fewer tests is you will be more productive. You will avoid that problem where we talked about at the beginning, where tests are seen as a burden or an overhead because the amount of testing is far less. And the maintenance and ownership of your tests will be far easier because you will have less of these implementation detail tests breaking all the time when you change things. Ken makes the point that dependency is the key problem of software development at all scales. I mean, really, essentially, he's talking about coupling. And as I've, transitioned in role over the last 20 years to take on more and more, lead architecture responsibilities, you really begin to realise that it's coupling that kills you every time. And when you own a code base, it's coupling that will kill you. Even back in the early days of the test-driven development community, I was one of the people that really came out and said, I was very concerned about mocks because I could see over-specification by mocks. I read Test Suite. Back a couple of things that you probably don't want to do. One was write an ORM, not a public one, but an internal one. ORMs weren't really that many of them in those days, back in the early days of .NET. We wrote something that was essentially an ORM ourselves, and it was a complete nightmare because we mocked everywhere. And those mocks knew everything about the implementation details. So, you could almost, for every line in our code, there was a mock testing it. And so whenever you try to change code, mocks exploded all over the place because the assumptions that those mocks were making about the order they'd be called in, the parameters they had, broke everywhere. And I came up with this notion of what we call over-specified software, where there were so much knowledge about the implementation details that your test suites became unbearable to use. And I don't think, actually, when I look back at it now, that the problem, I think I missed the heart of the problem. And the heart of the problem was not mocks per se. The heart of the problem was that our tests knew of our implementation details. If you think about a model where the domain is the core of your software, and that's really the thing that you're driving down to test. That's your plain old C#, it's your POCO classes. It's the surface of that domain that really is the core fundamental thing that we are testing, and not the implementation details. And that notion of over-specification kills us regularly. So decouple yourself. Your tests should not break when you change your implementation details. If they do, you're not doing test-driven development, because the benefit of test-driven development is to be able to refactor without breaking any tests. And I see people, I've had a conversation with people on Twitter saying, oh, well, I think, that you're being too assertive about this notion that tests shouldn't break, because surely some tests will always break. And you're not refactoring. If you're changing your public API, there are consumers outside of your assembly or your solution who may be using that code you don't know about. And therefore, they're not necessarily protected by your continuous integration environment. And as soon as you change that API, you may break them. Okay, so that's a change to your software rather than refactoring, and it has greater costs and requires greater scrutiny. Refactoring is this quick win to say, that's not quite how this should work, change implementation details. I've added a new feature, and I've realized now that the actual way we model this should change completely. When you get this right, you're constantly evolving the domain model. One of the problems I see with this kind of model of testing our implementation details of our domain is it makes domains very static, because people are afraid to change them because the number of tests that break. They say, oh, well, yeah, I can see that actually this implementation is wrong. We need a different approach to this now, much better design. But we break so many tests, I'm not going to change it, right? And the very thing, in a sense, that we promised ourselves test-driven development would give us, which was malleable software, embracing change, ability to refactor easily, has gone. In fact, the tests have made us fragile, made us rigid. And so we need to get away from that. And what we need to do is test the behaviors, test the public behavior, not the implementation details. Okay. Right, hopefully most of you kind of get that argument. Before we move on to the next phase, has anyone want to type in any quick questions that they may have at this point? There's usually some folks who regard this idea as kind of hits the spot on what they've been experiencing with test-driven development. Some people at this point find the idea quite challenging. But yeah, the key is, one of the keys is don't test your leaf nodes first. Test outside in, test your API, and then those two tests should emerge for you. I can't see questions in a second. We'll come back in a little bit. So some people occasionally say, well, hang on a minute, I find it really helpful sometimes without us having an algorithm to use tests to help me drive towards that solution. We'll come back to that as a problem. We'll explain how we fix that. Now, the question that sometimes comes up at this point in the talk is, isn't it going to require me huge amounts of setup code if I don't mock things? And we'll come back and talk about patterns to help solve that problem as well. So there are well-known understood patterns to solve these problems. We'll talk about what mocks are for really later. Okay, I can't see any questions, so I'll kind of press on. Right. So what I really want to talk about is just briefly was this notion of refactoring to patterns. I think Joshua Karetsky is really good at, got some really good recipes for how you do this. But I wanted to explain that this is part of test-driven development as originally envisaged by Kent Beck, and this table is something that appears in the book. And it tells you that some patterns are useful when you're writing tests. You can see the ones there. And some tests are, some patterns are refactoring targets. So even here, right from the kind of the original go of TDD, this is an approach we're talking about. This is why I say, think of this as TDD repeated, going back and learning the real craftsmanship practice here, not the cargo cult version that's been transmitted over the years. There are some, we'll talk about why things like factory and composite and selecting parameters and processes and that are useful in tests a bit later. This book, if you are interested in this notion of refactoring to patterns as a kind of discipline, is actually a very useful one for talking about how you can take code in one form and translate it into a pattern. But the goal was, when this book came out, people were really worried about how you apply design patterns, and this has become really the best practice for doing this. Okay, so in a diversion away from Kent, I'll talk about hexagonal or porcelain adapters architectures. There's a phrase onion architecture out there as well, which is kind of similar, kind of a reinvention of this idea, but we'll use the original term. It's not something Kent talks about, this is from Alistair Coburn, but it's something that I've found as an architectural style that's useful when you want to work in this particular approach. On the architecture I've used, I've born porcelain is here, and it helps you get a feel for where you should be testing. Okay, so before we get into the details of what a porcelain adapters architecture is, I wanted to talk about what's called the ice cream cone anti-pattern. So the ice cream cone anti-pattern emerges in organizations where they have too many tests which are really focused on the external part of the software. So they may have a number of manual tests where they, bash out on the keyboard with QA scripts against their website or their application logo. They may have a number of automated UI tests. And those are quite often really significant pieces of their test suite. They take a lot of time, effort to maintain, they run a significant number of tests, and they use point and click recording tools to record those tests initially. They may use things like Selenium, for example, in large quantities to get their browser tested. Below that, there's also some integration tests. We mentioned earlier that integration tests are a bit of a scam, but these tests were essentially they want to see parts of the system hooked up together. And then below that, there has to be a test. And one of the problems in the ice cream cone anti-pattern is that you can find places where unit tests are really a small part of test automation in that organization. And the bulk of the effort is actually for automating the UI or driving their spec flow or fitness test suite. And a large amount of testing is still manual. And the unit tests are really not driving code quality. I'll get to the question in a second. This diagram is not shown up very well in this PowerPoint view. But this is the alternative is the testing pyramid. And I'll explain it because you can't quite see it, but it's really a pyramid with 3 sections. The largest section on the bottom is unit testing. Unit testing should be the bulk of how we automate the testing of our software. Right? We should rely on those tests. One of the problems that I've had in organizations is people want, the particular QA teams, if you have them, want to write a whole set of test suites which mirror just what the unit tests tell you, because they can't trust unit tests because unit tests aren't real, right? And they go away and they write this whole set of additional suites, and then they go and they test them at the UI. Those should actually be less. We should rely and say, well, look, what can't we cover in unit tests effectively? What can our unit tests not tell us? Sometimes testing, for example, the actual user interface is harder than a unit test, and we want to test how some of the widgets behave in absence of our underlying API. Some parts of our code base may talk to third-party services, and we don't want to test those within our unit tests because they're slow and unperformant. So we'll write some additional integration tests to cover those slow areas. But we're testing the things that unit tests can't cover. So the first thing to really think about is say, right, what we're testing is unit testing, and we're using unit tests to test our software, and we're supplementing them where necessary with tests that cover the areas that unit tests can't give us coverage of. But don't flip to this model which says, actually, we're just testing everything multiple times. Again, it's the problem of not trusting our tests enough. Okay, we're saying we don't trust our tests, so we'll keep repeating the coverage of those at higher layers. When we think about the coverage of our system, think about it across all the types of tests we have, and rely most on unit tests. The thing is, unit tests give us the best feedback. It's in the most timely manner. You know, I've worked with test suites written in Selenium that takes hours to run, and you quite often don't get the feedback for a long period of time. As a result, they don't form part of the continuous integration suite because, well, your effective CI suite, because a developer can't check in, wait until the code goes green, and then say, okay, I'm going to hand on the token to somebody else to do their check-in now. What happens is the developer checks in, and the next day, the build goes red because it fails, and we've now run all the test suites, etc. And someone comes back to him and he says, well, it probably wasn't me, it was somebody else's check-in, because you can't actually have one person checks in and the next, because the test takes so long to run and no one can wait for them to finish. That's a bad model, and it defeats CI completely. Whereas this model, where essentially the tests can all run in about 10 minutes, you're reliant on those fast unit tests to give you a high degree of isolation as to where problems have occurred, are the way to go. So the first thing is we need to have a model that says we want to privilege unit tests over other tests. Let's look at this question. I think it's just the question we had earlier seems to have popped back on me, I don't know why. Okay. Right. Let's move on. Okay. This is a diagram of what's called a hexagonal architecture. Hexagonal architecture is just a logical view of the system. It's not necessarily physical, although you can, in your code reflect this particular model, and that's maybe a good thing to do. It's just another way of seeing NTS. So most of you, I'm sure, are familiar with the traditional NTM model. You have your presentation layer, and your services layer, and your domain layer, and some infrastructure layer as well. And this notion that you can only effectively depend downwards on things below you, not upwards. It's a very good way of building a system. It's a logical model. This just takes that essentially and says, well, we want to put a slight spin on that. So at the center of this diagram, the circles, that's essentially our domain model, right? And we can see that we represent a number of connections between those classes inside our domain model. The outer perimeter of that central hexagon, that represents the boundary of our domain model. And we call that essentially a port. And note that some of the classes are exposed over the boundary. There are connections going in. So they are essentially the API of our domain model. There is its public interface. Okay. Outside that inner domain model, we have what we call the adapter layer. Now, the adapter layer are things that use our domain model via the ports in order to provide functionality. So an easy model is, for example, if you look at the user side section, I've got, say, a REST library with API, OpenRaster, Stack Overflow, and it handles the business of taking a call in from the outside world, marshalling it to a controller. The controller then essentially is now under my control. In that code base, what I want to do is call my domain model via my port. So GUI adapters do the same thing, and ports are ingoing and outgoing. So at some point, I might want to call a database. And I might say, well, you know, I don't want the database to go to regular of my domain, so I will use a repository or a DAO, and I will actually wrap my database on my Hibernate or my entity framework layer inside that and call out. So those are adapters, and generally adapters are technology concerns. They're frameworks that are open source or commercial that you tend to use, and they're the things that solve something a nice, clean poker model in the middle. So we keep them all outside. And the adapters are things that might swap them out. So we might have new, you know, HTTP adapters because we decide that, you know, web forms isn't the greatest framework in the land anymore. I know it's a strange word to think that might happen, and we want to use MVC or we want to use Web API instead. And so those kind of swaps become easier if really we're just basically turning off that technology layer that takes in a request and marshals it to a call to our port layer, which in turn calls a domain model. Note that we don't directly call domain objects. So we're hiding nice bit of, you know, with encapsulation, we are essentially hiding implementation details, unless they are this kind of surface API layer. Now, there are different ways of doing this. You can imagine your service layer, your presentation layer as the port, and the domain model inside. So you're just using classes that are effectively your service classes, that effectively do coordination and control, don't have any state of their own, and just marshal call to a number of domain objects. You could use a command processor approach. There's one of those. If you go and look on my GitHub, just look at GitHub Ian Cooper, you'll find in the parent project thing called Brittle, which is an example of somebody using a command processor, which essentially says, I want to decouple myself from the framework completely so that at that point I will map a command which will generate inside your, say, web API, pass it on to the domain model, and it will build a whole pipeline to service that request and do IoT, and therefore I'm completely divorced from the chain and from that outside requirement. It can be very useful if you want to really reuse that in a number of spaces. Okay, so that's Hexagonal. They're a very useful way of seeing stuff. And you can also see, essentially, probably already the idea that you know, some of these adapters are things that you essentially might be mocking in a unit test for performance purposes or because they represent shared fixtures. So when we're writing our tests, one way to think about when this works is to think about that this port layer is really tends to be considered our use case boundary. It's where essentially we expose a use case, and it's the behavior of the system. And so it's at that layer that we write our unit tests, because that's the API of our system. That's where we expose our public behavior. That's where we can reason about the software, where we can say, I need something that adds together two currencies, two amounts in different currencies, and gives me the results. That's an API that I expose. I'm testing that here. Okay, that's where the unit tests occur, and that's something that's challenging to a lot of people because they expect unit tests to be occurring deep inside in that model. But don't forget, I'm writing these tests first, and those objects inside that central hexagon are emerging through my refactoring step. Initially, my API call to do that is essentially granular, and then I'm making it more, coarse rather, and I'm making it more fine-grained, more granular as up through the refactoring step. Okay. Integration tests, if we have to have them, are really when we say, right, some of these adapters, I'm probably going to, they're ports. So what I'm going to do is expose these outgoing ports probably as interfaces, where essentially my domain model doesn't want to know about the concrete details because I want to swap them out later. So my outgoing ports are probably an interface, and for testing, I may well choose to supplement that with some kind of test double, like a fake or a mock, for performance and to avoid shared fixture problems. And I might want to have an integration test to test that adapter itself. Then my integration tests will be quite specific in that case. They're not saying actually run the same tests as I run before, but just have a real database. They're actually saying just test the implementation of my repository. So if I've got, say, a currency repository or whatever, etc., the integration test tests that specific currency repository implementation, checks that I've hooked it up correctly, whereas for most of my unit tests, I'm just dealing with that interface. And it's these adapters, these outgoing adapters, that are key areas where we genuinely might want to use mocks. System tests basically exercise at the boundary, so I'm invoking my web API, I'm invoking my, I'm testing my browser. And again, these are the fewest number of tests we want. We've got coverage of our domain model. These tests are expensive to run, they're fragile. We create the fewest number of these. Okay. And I think let's go back, following that approach, I think hopefully will allow you to see that you can write far fewer tests than you have been by following a model of saying it's all about the unit tests, but it's all about testing the API here, and then just writing whatever integration tests and system tests I need to get coverage. Okay. Gears. One of the problems people raise when we talk about this approach with them, and you sit down with, I sat down with devs, Huddle, and we've walked them through this change in approach. And just to give people some feedback, once folks really get over the initial kind of scary hurdle of that's not how I've been doing it, that's my crutch, you're asking me to throw away my crutches and walk, which is essentially what we are doing, we're saying throw away your crutches and walk. Once you get past that scary, but people really embrace this. They really love the freedom it gives them suddenly to refactor, to change implementation details, the speed they can suddenly go at. It's still exactly the safety they had before. They are no less safe. But one of the indications comes up, people say, you know what, I've got this complex algorithm and I don't understand how to implement this API method. Right? It's too big, it's too granular. I don't understand how to implement it. I don't really understand how to do, and I like the fact that I can break the problem down to small bits and write my inner classes and assemble the whole thing up into one piece, because I could, that decomposition, something programmers always do, and now I've lost that, and you're making this big jump and I find that too hard. Okay, so Kent talks about especially gears. What he's saying is that this is a couple of things. The first thing is that we've got kind of like a fifth gear, right? And fifth gear actually says, when we get to that green step, when we're talking about writing simple code, sometimes actually, the gap between, it's a really obvious implementation. You don't have to worry that actually we're going to write the wrong algorithm and end up with code we find hard to get rid of because we're emotionally invested in it. It isn't actually part of the model. It's a very straightforward what we're doing. It's a well-known pattern. It's fairly obvious. I'm just going to write the actual clean code implementation right now against the original test. That's driving in fifth gear, and you're allowed to do that, but you should be careful. If you start to find that it's not going as smooth as you like, your test start going red, drop down. Better fortune should normally be, this normal test-driven development model which says, I write my test against my public API, and I refactor the implementation details out from that, and I can test against those very clear external behaviors. First and second are there for when things get sticky. First and second say, I'm really struggling to understand how to implement an API, so I'm going to drop down a level. I'm going to write some tests here to watch through the implementation details. I'm going to turn on assembly internals visible to an attribute. I'm going to so I can actually test some of those internals just to feel my way through the code. And it's helpful to do that. But the problem a little bit with it has become that people have mistaken that for what is normal test-driven development. And it's explicitly really first or second gear. And in the same way, I don't want to drive from London to Birmingham in first or second gear. I'd like to go on the motorway. I'd like to drive, in fifth gear occasionally. I'd like to drive in third and fourth quite often. Don't drive everywhere in first or second by making yourself do those tests for each method on each class all the way through. Okay. Drop down because you need to understand the algorithm. Right. One of the corollaries of this is there are two schools of thought on what happens with the tests that I've generated in order to feel my way through that code base. One school of thought says, well, it could be useful to the next guy. I found it hard, basically, to get this algorithm generated, so I'll leave them and the next guy can use it. The other school of thought says that you are coupling your implementation details to your testing. You should delete them when you've actually got the main external test passing and you're green. When I kind of initially, quite a few years ago, began to make this jump into this approach of testing, I remember several landlords saying to me, oh, yeah, no, just delete the tests. I was initially a bit hesitant, but now I'm a strong advocate of saying just delete them. And there are a couple of reasons for that. One is actually Misys has software. We could go back and find those tests we really need to. The second is if I'm genuinely coming up with problems that need to be solved that involve me changing the implementation details, then I may actually want to completely change the implementation. So those tests may actually be negative. By reinstating them, they actually keep going red when I try and change my implementation details. I want the freedom to change the implementation. If I need the help of tests again to navigate the algorithm, I'm probably best writing a new set of tests to drive the algorithm so as to encompass the new problem that I'm solving. So generally, I say delete them. Now, again, it's a similar problem. You know, developers, when you start pushing this start TDD, the first thing when you say to them, just delete the tests, instead of to kind of stand there, you know, willing them on to do it. You do it, and you know, at first, you can see them feeling this awful sense of, oh, I've deleted my tests. But you know what? After a while, they really begin to, again, as I say, really love the freedom it's giving them and the realization that they're not burdened by these things anymore. So I would say, if you have to drop the first second, delete the tests. The other thing, the reason it's really important is if you know that you're going to delete these tests, it stops you falling into the bad habit. Lots of us have learned really bad habits about TDD. It's not our fault. Blogs, books, everything taught this abstract, this method of saying test and methods under classes, and they're all wrong. They're not the way TDD should be approached according to Kent Beck, and they're killing us because they're binding our implementation details deep into our tests and slowing us all down to a halt. And the key thing is you're going to fall back into that trap if you just keep driving at first and second level with that comfort level. If you know you're throwing the tests away, and then you're going to think, well, I don't want to get too invested in these tests because I'm throwing them away. That discipline of throwing them away makes you not driving the third and fourth more because you're aware that those tests they're not absolutely necessary and wasted effort. Okay. I'm just going to drink some water, and while I'm drinking some water, if anyone's got a quick question at this point, it's a good time to ask before we get into that ATDD. Okay, I'm not saying anything, which either means you're all thinking I'm mad, or I'm joking so far. So, acceptance test-driven development. You know, it's been ATD. I think he provoked in one of his books on ATD, talking about you know, it keeps developers honest because they can write all the unit tests they like, but it doesn't tell you that you've met the functionality for the application successfully in its past. But having expended a lot of time and effort at various companies on, you know, fitness test suites or, you know, and even touching spec flow stuff, I've really moved against it. This is a classic ATD cycle, and so the idea essentially is that we will also discuss the story and we'll come up with essentially a set of acceptance criteria with the product owner for how the story, what acceptance is in the story. We'll then distill those down into a series of tests. We'll use those to drive our development. We'll demo to the user, and we'll say, does that meet your requirements? And it's a way of driving this agile story cycle successfully and having automated tests prove this happened. Right. Kent Beck originally let's come back to this before I show that. Kent Beck is a book in his series, his signature series, on acceptance test-driven development. Originally, what happens is in his original test-driven development book, Kent said he didn't believe in ATDD because he didn't believe that genuinely product owners would become involved in the process of running tests or specifying them, or that would find much use in these text-based tests that were exposing the system functionality to them. Later on, when he obviously had an ATD book in his series, he had to kind of justify why that book was in his series. And what he's saying is there's a problem with TDD, and it can devolve into a programmer's technique. And the ATDD, making tests, a mechanism for communication between developers and the product owners, was a really valuable kind of practice. But the problem with it, I think, a little bit is it's kind of missing the point. And James Shaw, who was one of the guys that wrote Fitness originally, and who is worth reading his stuff on Agile. He's written one of the best books on how to do Agile for my money. It's worth checking out his blog and stuff if you don't know him. But he's one of the guys that wrote Fitness said, you know what, it's not working. He said, The trouble is that Kent's original assertion that customers don't participate tends to be true. The problem with ATDD, though it seems very good in practice, is that there are very few product owners who generally will sit down and write the tests. The other problem becomes, in my experience, that if you're using a test suite like Fitness or SpecFlow, is that they become so expensive to write because each one requires a kind of custom implementation of the fixture in order to actually drive your underlying code base, that you begin to put constraints on them as developers to say, well, actually what we need to do is create some kind of, and we start talking about ubiquitous language or DSL for implementing our tests in. And you start saying, yeah, we're going to basically constrain the terms of the language, and you guys are going to write the tests in this language, and that's going to help us basically agree the language. And actually what you end up doing is writing some really poor programming language in a text-based tool that's not very good at supporting language generation. And it becomes very, very expensive, and the tests are very easy to break. When you change requirements, they break very, very easily. There's no refactoring across your tests. You can't change the test cases very easily. The whole thing is very, very difficult to own. And it turns out, James' proposition is, and which I think I agree with, that actually the value from the ATDD process didn't come from having those tests for SpecFlow and Fitness. It came from the discipline of us saying, let's sit down, generate acceptance criteria, and use them to drive our test suite. And having those tests in SpecFlow or Fitness is not the answer. Having those tests in our unit test suite is the answer. And once you begin to get back and realize, well, what Kent was originally saying was test behaviors, then there's no distinction between these ATDD tests and actually our unit tests. They're the same thing. We're testing behaviors in our unit tests. So the ATDD problem seems to emerge because once we misunderstood what unit tests were for, and imagined they were about isolating systems under test, so that we were only testing classes or methods under classes, we needed ATDD to try and provide the missing behaviors, the use cases, the context, the understanding of our system. Crazy, because those tools are actually really quite difficult to maintain and expensive to own. Better off to actually just take our unit testing tools and use those to drive the behaviors. And once you do that, you begin to see this synergy with what TDD originally was and why Dan North called it behavior-driven development and said, you know, we should write tests against the behaviors and refactor out the implementation details. As soon as you do that, this need for ATDD mostly evaporates. But you have to have this life cycle process where you involve the product owner in specifying the test, but you can now directly write them as the unit tests. That may mean you need to get QA team people or product owners to look at your code, to actually look at the tests you've written within MSpec or NUnit or whatever your preferred unit test framework of choice is. But that's okay, because when you write tests against behaviors, they should be much more comprehensible, and making those tests comprehensible is a far better goal than this separate test suite that no one really loves. So yeah, I think the problem is, like I say here, just really that ATDD was solving the problem that we created for ourselves by misunderstanding what unit tests were. We need to go back and understand what Kent said unit tests were, which are tests that are isolated, not systems under test that are isolated, and that we should be testing behaviors, not testing implementation details. Okay. I want to talk briefly about behavior development at this point, because obviously we're crossing over with that particular idea. So BDD started with the same insight. Dan, in his original blog post, observed exactly the same thing I'm talking about now. People have misunderstood test-driven development, and they imagine it's all about testing methods on classes. It's not. And Dan was genuinely puzzled. He said, I can't understand why people actually think it's that. It has nothing to do with what the book says. So his original goal in creating this new name, behavior-driven development, was to focus people's minds on the fact that what Kent was talking about was testing behaviors, not about testing methods and classes. As a result of that, what happened was that he went away and wrote JBehave, which created RSpec. And then they began to realize that this need for acceptance integration tests was fading on them, because actually they were the same tests that they're writing for their unit tests. Began to get into the person saying, well, actually, we should get product owners to specify the tests. If you're going to listen to people like Liz Keogh talk today about BDD, one of the key points she'll always emphasize is that people who think BDD is about SpecFlow or Fitness are missing the point, or Cucumber and Ruby land. because what these things are actually about is not the tools, they're about the conversations and the processes that occur. BDD is now essentially a full Agile life cycle. I urge you to go and check it out. It's very interesting. This presentation is not about BDD, but it starts by saying that Dan North's original insight was correct, that test-driven development, as understood in a large range of books that have come out and presentations and blog posts that have come out since Ken wrote this book, is a misunderstanding because of the misunderstanding of the word you test, and rephrasing as behavior-driven development may help some folks to understand that behaviors are at the heart of TDD, not methods and classes. Okay. Let's talk about mocks briefly. Okay. What are mocks for? Ken talks about mocks. So what are mocks? So the classic example we might want to mock is a database. We don't want to actually talk direct to database in our tests. Why? Well, shared fixture is the primary problem for Kent. That's the reason he wants to remove it. And solving the shared fixture problem can be done by, opening transactions, then uncommitting them at the end, so that rolling them back at the end, rather, so that they never actually write to the database, or just doing recreation and destroying the database at the beginning and end, or doing it in-memory databases so it doesn't really work. All those are valid solutions. Another way is just a mock. And Ken identified that mocks can be useful. If you're using hexagonal architecture, mocks are certainly great for outgoing ports, where essentially what we're saying is we're communicating outside the boundaries of our system to our domain model something else, probably another system like a database or another third-party system, and all I really want to check is that my domain model sends a message externally correctly. I don't want to check my internal interactions with that, so I'm going to leave it alone because it'll be expensive and slow to test if I actually try and do that in a real environment of flaky. So it's about a pragmatic decision at that point to say, well, let's be on the port, don't include it in my test. It's expensive and hard to work. Okay. It's not a theoretical thing saying these be isolated as a unit test. We've established that. It's just pragmatic. Okay. Yeah, the other reason mocks tend to be used is a lot of the responsibility-driven design guides. So you can go and read, say, Matt Price and Steve Freeman, Growing Object-Oriented Software That Tests, and they use mocks to help them drive a responsibility-driven design process, particularly this idea of tell, don't ask. The idea that we don't want to expose the implementation details of our classes, so we should tell classes to do things, and that one way of us making sure that we follow this approach is by using mocks so that our classes interact with other classes, not by setting properties, but by checking methods and passing them across and that kind of thing. And it can be a valid strategy to do it that way. I don't think it's in contradiction to what we're saying here about TDD, because I think in most cases they'd be concerned about public classes, talking about the public classes, not about implementation details, talking about implementation details, and mocking helping you get past that model of message passing. However, it's an interesting point of kind of some conflict between us. Okay, but you can certainly use it with this approach. Just make sure that what you're mocking, the collaborators, are other public classes, which you're sending messages to that you're providing your domain, as opposed to internal implementation details. So this is hexagonal architecture again. You can see that essentially this ports boundary layer is the layer that we mock at. Things on the other side of the ports boundary layer from us as the domain model code, so mainly outgoing, are things we mock. So we mock our port, not the actual thing. So I don't want to mock in Hibernate, I don't want to mock my SQL database. What I want to mock is my DAO or my repository, because you only mock things that you own, not things you don't own. Okay, don't mock internals, we might have public classes, so I'll explain all that. Hopefully you get where we're going with that. So these tests which I see around where you get a class and every single dependency it has in its constructor is mocked, that isn't the way to go. Right? A lot of those dependencies should be concrete and used if they refer to other domain models, classes in the domain model. One of the corollaries, the problem that I see occasionally, is when people use IOC containers inside their domain model. Never do that. That's a really bad practice. Within the domain model, if you have to do injection, you should just do it directly by calling the constructor or using factors. IOC containers are a framework concern. The only place they should really be is where you are instantiating pipelines to deal with requests from one of your adapters. So your port layer may well use an IOC container to establish the things it needs to complete the request, but your inside domain model, you should never use an IOC container. And people have got into this strange habit of creating classes from IOC containers and bringing and auto-mocking in all the dependencies, and it's really, really bad. Please don't do that. That's a kind of bad, wrong kind of approach. Your domain model should be pretty much self-contained away from frameworks, including your IOC container. That's a framework. You haven't got POCO if you've essentially got your domain model depending on IOC frameworks. So make sure that you understand that kind of distinction. And as a result of that, you've put up to take concrete dependencies in those classes. Okay. The thing that comes up then after that is if I'm not doing mocking and I'm actually using concrete dependencies in a number of cases, I may have a lot more setup code. And potentially even, a lot more teardown code because we have teardown code because actually we may have, we need to make sure we don't have shared fixture issues. Okay. So how do I do that in a way that doesn't require me to write hundreds of lines of code? Okay, so Object Mother was the original solution to this idea that was done, I don't know, 2005, 2006, around there. The idea was that when our test needed domain model objects, which themselves have dependencies, etc., and were expensive to construct, we just called a little service we'd implement that would give us instances of that object back. And the idea was that we'd give it an expressive name that told us what kind of object we were creating, and it gave us back those objects. And over time, what would happen is we'd learn about these particular object mother methods that gives back these classes. So it's a giant factory object mother with a whole lot of static methods giving us back instances of stuff. This is kind of an example. I was obviously at the time watching Sherlock, I think the last series, and you can see we've just basically got a static method that we're calling on a class that's saying give us back an instance of an invoice for a deerstalker and cape and sword stick or a deerstalker and boot. So you can see we're being expressed about what's inside the returned objects that we're using in our tests. Okay. Object Mother ran into a number of problems, and when I've used this in the past, the particular issues we hit were that you get one of these well-known methods, and one of your buddies would start modifying it to do things he needed in his test, and that would then start breaking your tests, and you'd have to go and say, "Why have you changed my test?" You then realise that actually he couldn't share one, so you'd fork it and create another. You get an explosion of a vast number of these methods. You would start with 4, we end up with 100. Tests would get deleted, but Object Mother creation methods wouldn't go with them, so you have this crud building up of a whole history of them, and it became very difficult to own. So we wanted something that took this idea forward, but wasn't the same. So what we did was we moved to tentative builders. Tentative builders were this idea where we'd say, right, what we need to do is have a builder that can construct instances of our object for us. If we just want a plain object we don't really care about its contents, we'll just call this builder and say, build me one of those, and it will create something with set suitable defaults. If we need to care about specific properties it has, we'll set up overrides in that builder. We'll pass in saying, okay, actually give me a invoice, but this one should have a deerstalker and a caper, so we'll basically create methods to allow us to set those values. Generally, the way you implement it is you use a fluent interface, and to do that, we say that each method call returns this. So it returns basically the builder itself. So you can chain together that train wreck syntax, that dot syntax. So you can say something like, new invoice with deerstalker with cape. Right? So we kind of show an example here of kind of some sort of implementation of that, where essentially we've got basically a build method which creates an actual instance of it, and a whole lot of with methods that allow us to add given values into it. And we have kind of like some other builders we're using ourselves internally to construct other instances by default, which we can then override. So we either basically get the default invoice lines, default discount, or we actually override them and get a new discount. Okay. the advantage of these kind of builders, what happens is that we only use those with overrides because those things we need to change are important for our test. It's this notion of evident data in testing, this idea that when I go look at the test, I can clearly see that I'm creating a invoice, and I can clearly see that in this particular case it's important to me that there's a discount. So the discount must affect this test and must affect the results of the test. So it's highlighting those values that are important to the test, but hiding the others from us. And so therefore that helps us clean up our setup by saying we don't have a lot of noise, we're just isolating it to be the data that's clearly important and relevant to this test. Summary. Okay. Just the complexity around this test. In terms of setup and creation, now we are using concrete object-side dependencies. Okay. Right. So let's summarize briefly the kind of key points that you should take away from this if you want to kind of improve your TDD practice by really going into what Kent Beck was originally talking about and what Dan North was talking about when he coined the term behavior-driven development. The key facts are the reason for to create a test is a behavior, not a method. So think about what behavior I'm implementing, write a test that expresses that behavior against my system. Write that against your port layer, your service layer, your internal API, not your external API, your internal API. Go green and then refactor. And when you go green, be dirty. And when you refactor, don't write new tests against those implementation details. So no new tests refactor internals and privates. You shouldn't have tests against internals anywhere in your code base. And you shouldn't be making everything public just to get around that and start testing stuff. Make sure you encapsulate properly. Development again, the port explains. Integration tests should just be about coverage. They should be about saying, okay, I need to check that my implementation of the repository pattern calling in Hibernate here will actually work, because everywhere else I've mocked it out. Add system tests for confidence that actually, okay, when I basically call my web API endpoint, it's going to actually pass that call through to my port, and that's actually going to call my domain model and return results to me. I want to make sure the whole thing is hooked up together onto a system test, right? But in those integration and system tests, don't recover the same old ground continually. Right? Don't mock internals, privates, or adapters. Right? Don't mock things we don't own. Don't mock things that should be internal. Don't expose our implementation details and couple our implementation just like tests. Just test the ports rather than the adapters. If you do that, the result will be you will write less tests. You will refactor easily because you are changing the implementation details. You will understand what it truly is to refactor, to really radically change your domain model, but the tests keeping your public contract available. You'll be much more productive because that removal of that coupling means you can go forward and modify your software much more easily. Okay, I think I've got a slide for Q&A. If I haven't, yeah, okay. So we'll go into Q&A. I'll try and okay, so I've got Adam's got a question, working with legacy code. Okay, right. Talks about gradient test, towards identification of failures. Yeah, it's a good question, Adam. Have we stopped identifying failures because we're not narrowing you down to an internal implementation detail that particularly has failed? Actually, I find the opposite is really true. If you test implementation details, you find that actually you get a sea of red because 20, 30 odd tests will break. It doesn't help us narrow down at all. It actually confuses the issue. We're having to go through those tests trying to see if they all relate to the same problem. If you test at the API layer, one API element tends to fail, and you tend to find that that's the cause. And if multiple API elements fail, you're worse off. When you have a chain problem or implementation details, it's very hard to see the wood for the trees. I think this gives you similar granularity about what has actually broken. So I don't think that going lower really helps you. I think actually it makes identification harder, not easier. It's a great question, but My practice so far has been that it's actually no real advantage there. How do you approach testing the data access layer is another question. So I hope we've kind of maybe covered that a little bit, but our domain model should be isolated from all framework concerns. That's where our unit tests are mainly should be focusing. That's our sweet spot. Data access layer essentially is in kind of a port adapters model is basically an adapter. So we're testing out the domain model, and calls to our data access layer are coming out from our domain model, and they should be behind a DAO or a repository. So I would tend to say, well, you know what, for performance and to avoid shared fixture problems, it's just as easy to essentially use a test double like a fake or a mock to say we're calling that external repository to do stuff, or we're getting values back in that basically help our test move forward. So maybe you guys understand the distinction of fake. A fake says I actually need some inputs. So within this piece of code, I've got some code, information from database, and I'll therefore fake that out. Or basically it's a testing an output, in which case like a mock, I'm saying I called the external system correctly. I would tend to use fake test doubles for those at that boundary layer because it prevents shared fixture problems very easily and it makes the test fast. So by the way, at the port layer, you tend to have a model which tends to say, go and get stuff from external places, other ports, external services database, then essentially call my domain model, do stuff with it, because you're initializing the state of the domain model essentially with those calls. So you're saying, get me actual entities that have data in them. Expose the domain model, that's really the key thing that you're actually getting under test. Everything else is kind of mocked a bit. And then essentially publishing any savings or reports, etc., publishing other services that I need to do as a final step. And again, you're probably checking mocks and ports on the outside. Okay. Another question: How do you see TDD as you describe it in league with design-driven testing? Design-driven testing is not really a acronym I'm familiar with, so I can't really answer that question fairly. I'm not sure what design-driven testing is. Obviously a new link I need to look at. Okay. Finding time that works to write unit tests. Sometimes I don't TDD, but I do write my classes properly tested. How do you feel what the time for testing is important to actually go code? One of the things I think with this model is you can write a lot less tests. So that reduces the cost burden considerably and helps with that argument. What we tend to do is never actually explicitly say we are writing unit tests as a thing. We just say we write code, and the way we write code is to do test-driven development, and we don't separate them out. We say, well, our analogy would be, it's a bit like saying, I want you to write me a letter and taking away my pens and my typewriters if you take away test-driven development. Nowadays, I think that some form of test-driven development is such an accepted practice that people who advocate not doing it are being a little crazy. I think the reason they do it is they see it adding a lot of cost, but certainly in this model you write so fewer tests that the costs would go down considerably. What do you mean as a scenario test? Calling a survey if you're not in the right order. Scenario test. What we mean is that a scenario is really just when we define a story has acceptance criteria. Those acceptance criteria drive tests. It's easiest to think about those tests in the form of concrete scenarios. So sit down with the product owner and say, okay, when I add $30 US to 15 British pounds, I expect to get whatever that figure would be, right? That's a scenario. We then translate that into an actual test in our unit testing code. Whereas before, under some models of this, that would form an acceptance test. We say actually that forms a unit test written against our code base. What are the best strategies that work cross-platform? Okay. That's amazing detail because we tend to only work in the environment that they were created in. I'd like to better make .NET tests work on, say, PHP. Not quite sure of the model there. And obviously, unit tests or developer tests, by their definition, tend to be exercising the code quite directly. Because they're exercising that code directly, they'll tend to want to be hosted in the same runtime, so the CLR, for example, so you tend to be writing in the CLR language. We tend to write the tests in the same way as writing the coding because it prevents semantic dissonance for the developer in switching between two languages. We start to write our acceptance tests, our system tests, really not acceptance tests, but our system tests in Python for exercising, say, our REST API. Because we find that it's helpful to think about shifting to a different language, both in terms of making sure other consumers and different platforms can use our code base successfully, and it prevents developers feeling that they are writing the same test twice. And what we really want to do is exercise something like basically just get hold of the XML or JSON, check it's basically correct, exception just for the stuff we're not covering in our unit tests. But as for writing tests that are multi-platform, I would, for me, that I would want a question on what are the platform elements that I'm kind of merging here. So I'm not quite sure I understand the question. .NET test working on PHP, I'm not quite sure what I'll be doing. I'll be testing .NET test to get PHP. I guess I could be driving using .NET to test a PHP website, but I would tend to say falls follow the ice cream cone model there, where essentially you're testing the externals rather than the internals. I try to test the same thing. So you believe that TDD can fully remove the need for integration black box testing. TDD can't fully remove the need. But I think TDD you should rely on your TDD tests more than we do today. So there's always a gap in coverage, but I don't believe we should cover the same things twice. So what I mean by that is when we tested our domain model for our ports, when we look at the adapters, we test essentially the port that covers that adapter as an test implementation. We don't want to write a new end-to-end test with a solid version plugged in. We say when these two bits come together, they'll be fine because we tested this and we tested this. We believe in both those test suites are correct. All we might want to do in the system test is have a confidence testing that the whole thing plugs together. But generally, I'd say when you get to integration testing, express what it is you are genuinely testing. If I'm genuinely testing that my repository, my Hibernate mappings are correct, test that explicitly. Don't test your entities to do with your insurance system with database intact, just test your own hybrid mappings. Explicitly test that bit that's missing. You genuinely will always have some pressure for testing black box by our QA team. While we have some Python tests, for example, for exactly that reason. What we try and do is get them to work with our unit tests and convince them that they don't need to basically cover large numbers of eventualities in those tests and just repeat the coverage we already have. One of the ways to do that is to really get your testing QAs much more invested in the code, and remember to think about the fact that those guys nowadays, because they're doing not test automation, tend to have better development skills than they ever used to. Okay, so now I've been translated into a few tests in new meaning. I think what you're asking is, do I mean a given scenario can be a few tests? That's how long is a piece of string? It depends on the gravity of your scenarios. In a scenario expressed as something like, when I add a currency in this amount to this amount, another currency and get a result, that would be one test. That would be a test that you're expressing as a public API that ought to be giving you a method called add two currencies. Right? So that use case, that level is what the level you're testing it. Don't break it down into saying, oh, I'm going to check my currency converter rate thing and that thing. That's testing implementation is at that point. So try and avoid that.
So thanks for that, Ian. That was a good session. Can you turn your speakers on a little bit, please?
I will do it. Hang on, I'm just trying to find out where the speaker section is. It's pause sharing. Okay. And okay. I think it's